So today we are talking about square roots. On Friday we got kind of like a preview of what square roots are. There are some things that tend to trip people up. We'll talk about those. And we're going to talk about ways to break down square roots. My first question is, what is the square root of 25? Essentially, well, let's start here. Michael? 5. All right, so what he's saying is 5 is the square root of 25. So that means if I had an area of 25, the root, the base of that square would be 5. So we can check that by doing 5 times itself, which equals 25. Is there any other number that I can multiply times itself to get 25? Emily? Negative 5 times negative 5 also gives me a positive 25, remembering our multiplication properties. So when we ask for just what is a square root of a number, it actually has 2 square roots. It has both a positive and negative square root. So every square root will have both a positive and negative. What will be important is reading what is it that they're asking for. Do they want to know the positive, do they want to know the negative, or do they want to know both? If you have a square root sign that looks like this, there's no sign out front. All it is a square root with a number on the inside. They're wanting to know what the positive is. Just like when you write your birthday, you don't put a positive sign in front of your age. That wouldn't make much sense. The idea is that it's always positive. Any number by itself is always positive. So here they're asking for what's the positive square root of 9. What is the positive square root of 9? 3. Good. So your answer there would be a 3. It's also possible that they'll ask you for the negative square root of a number. And this is how they ask you for that. They're asking you, what is the negative square root of 81? Because remember, every square root has 2 answers, both the positive and the negative. The sign out front is asking you for telling you which one they want. So they want the negative square root of 81. What is the negative square root of 81? Michael? Negative 9. Very good. Every so often, they're going to ask you for both. And this is how they do that. So they use both the positive and negative symbol in front of the radical. That square root symbol is called a radical. You may remember what the number inside the radical is called? It was in that video we watched on Friday. It's the radicand, yes. Very good. So the radical is that square root. The radicand's inside there. So they're looking for both the positive and negative square root of 49. What is our answer for this one going to be, Toby?
Negative 7 and positive 7?
Yeah, both a negative and positive 7. I would write it like that, just with a plus and minus 7, because that recognizes that there's both. Those are the primary ones that you're going to face. Positive square root, negative square root, and then both positive and negative square root. Every now and then you're going to get crazy ones like this. Square root of negative 4.
Right? Negative 4 is that?
The square root of negative 4. right, you've had a minute or two to talk about this. What conclusions has your group come up with? Haley? It's an imaginary number. What do you mean by an imaginary number? Okay, so there's no square root of a -4. I still see some hands up. Scout, what did you guys talk about?
Well, I thought it's an imaginary number because there's a question that has no real answer.
Interesting. So there's a question but no real answer. I like the way you said that. Yes.
Domain error.
Oh, so if you just straight up put in your calculator, it gives you a domain error.
Yeah.
Error. So it makes you think that maybe that can't be done.
It's -2 times +2, but it's not like.
Yeah, if you do -2 times a +2, that'll give you a -4. But the problem is you can't. That's not a square root. A square root is a number times itself. Well, it is an imaginary number, and we're not going to go into the greater detail of what complex numbers are, which is what that is. We use a real number system that's in a complex number system. Imaginary numbers represent this idea that there's something that can be taken from nothing. All you really need to understand is that an imaginary number is pretty much the same as a -1. It's not really the same as a -1, but for our purposes, that's how we'll be using it. You'll be using it a lot more in probably Algebra 1, definitely Algebra 2 quite a bit. That's where you'll be developing kind of that complex number system. So when we want to find the square root of a -4, what we're going to do is we're going to apply this idea that we can have a -1. So that is going to represent that negative, so our answer could just be 2i. So it's the imaginary, so 2i would just be imaginary 2. There are some more that I wouldn't mind going over. For example, let's do the negative square root of 75.
Negative. Can we discuss it by group? People understand that?
Alright, so I asked you to find the negative square root of 75. Anybody come up with an answer? Nathan?
Negative 8.660025.
So negative 8 point, and then it was 66025, you said? I'm just going to round that to 0.7. There are actually a couple different ways to write this. One way is to write it as a decimal. Another way is to write it as a reduced. To write it as a simplified or reduced radical, what you need to do is find the factors of 75. So for example, inside here, I could actually write the factors of 75. What are the factors of 75? Now keep in mind we're dealing with square roots, so we're looking for perfect squares. Which one? 15 times 5 will work, but those aren't perfect squares. So I'm looking for something that I can reduce. Think money. Something that I could reduce. Sure, I could do 25 times 3, can't I? 25 times 3 gives us 75. Do I know the square root of 25? I do know the square root of 25. Do I know the square root of 3? No. So what I'm going to do is I'm going to put the negative and then the square root of 25, which is 5, out front. And since I don't know what the square root of 3 is, I'm going to leave that as a radical. Yes?
Can you write it in a decimal form?
We'll go over that. There's two ways to represent these. This is a simpler approach. This is a more useful academic approach. Now, for most of what we'll be doing this year, this will be sufficient. However, there are people in this room I expect to do this. If you feel like I'm talking to you, then you probably ought to be doing that. So I'm not going to give you an answer, is the decimal good enough? You'll know who you are. Yes?
So if you go to this one or one plus the other, start with this one.
Yeah, I think it will. Yeah. Let's try another one of those and see how it goes. I want you to try and find both, the positive and negative. You can write it as a decimal and simplify it. So when you break it into its factors, think perfect squares. Somebody who wrote it as a decimal, tell me what you got. Michael.
Negative and positive 3.5.
Rounding to the nearest tenth, we got 3.5. Which, by the way, I should mention that these decimals are irrational decimals. They go on forever and never repeat. Those are irrational. All right? And if we reduce that, what did you guys get? Scout?
Negative and plus, and negative and positive 2, and then 3 squared.
You mean square root of 3?
Yeah.
Yeah. So what he did was he broke his 12 up into 4 times 3, because 4 times 3 gives you 12. We do know the square root of 4. It's a perfect square. We do not know the square root of 3. So that's what it reduced to.